Okay, I'm William Kell, and I'm a licensed electrician in Georgia, and I'm going to explain today how, from a power, really a conceptual power standpoint, how you put in a standby generator. The reason I'm doing this work is because I can't find any place else where anybody else has done it. The videos that I've watched on YouTube, they seem to hide this part. Well, not always. I've seen a couple of times they've explained it, but usually they don't, and I don't know why. So I'm here to explain it. Okay, here you go. Diagram on the left. Power comes in. You're going to put in a standby generator. Power comes in. In this case, we're going to say from a weatherhead, it goes down through into the meter box. There's a circle up there that stands for a termination of a cable. And then you see the two lines. Those are plugs. So that's built into the meter housing assembly. And then you have the M, that's the meter. And same thing on the bottom. Another plug. And then there's a wire at the bottom. And then that goes to your main panel in your house. So what we want to do is we want to make it where we can have a standby generator system. So what we do in short notice here, you can see it. Look what we're doing here. We're coming from, we're not changing anything until we get to the bottom of the meter connection. And there we disconnect the wires that used to go to the panel. And now we're going to put in new wires to go to a transfer switch. As you can see, that's the red. And then we also have to run a set of cables from that same box, assuming we have the right volume. We don't violate the NEC volume rules, and we make a connection there. That's going to add another 6 connections. So we're going to have, I think, 12 connections if you count them all. So we need to look at the NEC volume and make sure we can do it in that box. So as you can see the cross lines, the green cross lines, that's the disconnection. And so these wires that used to go from connected to the meter are now going to be connected to the transfer switch, as you can see. And then, of course, we have the no-brainer coming in from the generator. You know, everybody knows how to do that. So, and you see some contactors here and things like that. So that's that. Now, if you want to see that, sorry about that. In 3-line form, there it is. Okay, same thing. I'm not going to go through all of it. And that's the, let me add these out of order. Hold on. Yeah, sorry. Let me start over here. This is the before 3-line. Okay, and then again, this is the after 3-line. Okay, now there's a lot of notes on here, so you read them. One thing I don't know about, I haven't researched it, is that the automatic transfer switch was consist of 2 contactors that are mechanically interlocked. One of them is going to have to be bigger than the other, or they both need to be the same size, which really wasted a lot of money because you only need 107 amps on 22 kilowatts. And for a 200 amp service, you're going to need 200 amps. That's a much more expensive contactor. So I don't know how these people accomplish all this. This is all just theory. This is my opinion of what has to happen on paper. And of course, what happens in real life, the actual trade work is very complex. There's a lot of tools needed, but this is how it's done the way I see it.